Hello. In this video, we're going to go over how to use Firebase's real-time database. And we're going to do this in order to make our React Chat application work. So that's the general idea, right? We have our React Chat application. We are able to post messages to this. It all works fine. We're going to make it so that these messages persist when I refresh the page, and they can be then sent from multiple accounts on multiple computers because they're all being stored in a remote database. All right. So in order to do this, we're going to be building using Firebase's real-time database. So we go start at our Firebase console. If we go to build, we can go down to the real-time database. This is what we're going to do to actually manage and store data. Note that we are not using the Firestore database. We are not doing Firestore. We are using the real-time database. Now, of course, if we specify the real-time database, Firebase immediately says, are you sure? Did you actually want to use Firestore? Firestore is their newer document-based data structure. It works in fundamentally the same way, but it's a little bit more complex in terms of actual data that gets stored. We're interested in working with a real-time database. It'll work with JSON structures. It'll work really, really cleanly, and it supports real-time updates so that whenever the database data changes, like when someone posts a message, we'll be able to see those updates live. It does it in real time. It works a lot better for most of our purposes for this application. So in this class, for sort of what we're working with, we're working with a real-time database. Okay, so we can click on that option from the sidebar in the Firebase console, and then we can go ahead and get ourselves started. So the first thing we're going to do is we're going to create our database. So we're going to click that big create database structure. It's going to ask us where this one, like which on Firebase's servers, data centers should this get stored. US Central is fine. It really doesn't matter too much. If we store it locally, they'll be better. The next thing it's going to ask us is to specify a set of security rules. The security rules are used to manage who is allowed to access the data in the database. Security rules are specified through this kind of weird JSON data schema. So in this case, we're going to have an object of rules, and the rules are going to basically say who is allowed to read the data, who's allowed to see it and see what's in there, and who is allowed to write to the data, who's allowed to change what's on there. By default, if you don't do anything else, or if your database starts out as being locked, nobody, is someone allowed to read it? No. Someone allowed to write it? No. False all the way through. You can then, of course, customize these values to indicate sort of whether users need to be authenticated and what situations are they allowed to read or write what parts of the database. We're instead going to start in what's called test mode. Test mode is going to let us use a set of security rules that say that they're allowed to read if the current time now is less than about a month from now. And you can see this is about a month from when I'm recording this video. They're allowed to write from now is less than, again, about a month from this video. So this basically says that everyone's allowed to access it, right? No restrictions. Everything can work fine for the next month. This is good for testing and debugging and sort of getting everything up and running. Most projects you'll be building, you're probably building within about a month time frame. And you can, of course, always go update this time later if you need to have something extend in other ways. There's a lot more details about how security rules are used on Firebase documentation and the textbook. We're not going to go over it too much in this video. We're going to set ourselves up in test mode, and that'll work fine for our purposes. All right, we can then click enable to get our database up and running. With that, we now have our database. And this is a snapshot of what our database looks like. Note that there are other tabs here. If you want to go modify your security rules, there's a rules tab. You can also see other pieces of information as well, but mostly we're going to be working with the data. Okay, this is a picture of our database. You're going to want to have this open all the time that you're working with Firebase's database, so you can always see what's happening on the server. Now, the database, right, here's our database. That's our sort of location. Its value is currently null. There's currently nothing in our database. The best way to think of the Firebase database is really as a giant JSON object that's floating in the cloud. So we can imagine sort of like here's our database, right? It's almost like we're defining a variable, right? Our database at the moment is just null, right? That's our whole thing that we've created. From this web interface, we can go ahead and add data and customize what's inside of here. So we can click this little plus button in order to add a new key value pair, because this is a big object. So we add values, key value pairs, just like we would define as an object. So for example, I can give a first name key whose value can be Joel. And when I hit add, notice it adds that first name, key Joel. It all highlights in green to indicate that we're adding a new element, right? I can add another one that could be last name, Ross. It highlights in green for when you're adding new elements, and the things that highlighted in yellow are changing, right? The database is being modified, so it's showing you that happening kind of in real time. So what we now have is we now have something that's a first name, that's Joel, and a last name, it's Ross, right? That's what this is what our database looks like. We can add more pieces as well. So for example, maybe we want to put a topics list, and the value from that, we can actually add additional pieces. Oop, no, let's delete that. If I delete it, it turns red for a moment and then disappears. Try it again. So this is going to be value, or no, this is, I want to say topics. We click the little plus button next to it. That lets us add nested pieces below. So maybe this is going to be topic 1, can be JavaScript, or it can be React. Right, we can add that guy in here. And now we have a topics structure that has a topic 1 React inside of it. So this could be topic 1 topics, now has a topic 1 React inside of it. This is, in theory, this would make sense as an array. You can't quite do arrays in Firebase. We'll talk about that more a little bit later in the video. Cool. So again, this is our interface for letting us see what the database looks like. And again, I can delete chunks of it directly from here. They turn red when they're getting deleted. This is yellow because it's getting modified, and that changes what's in our database. So now my database is getting back to structure and just having these 2 keys, these 2 values directly inside of here. Okay, that's our database. Again, you always want to have this open because you want to be able to watch what is changing in your database as you modify your application, so you can see what's going on, right? You can see, is there actually some content showing up there? Okay, cool. So that's the basic idea. Now we can actually go ahead and make it so that our app will be able to update our database. So we're going to start by doing this by making it so that when I submit a message, right, when I type hello world here and I hit submit, instead of having it write to the state and show up in this app here, we're instead going to have that get sent over and added and pushed into the database. So if we go to our React application, and so it's a React application, you may recall that we have our function here inside of app.js that lets us add a new message to our state. This works off the form, where the user types in what they want, and we figure out who the user is, and we create this new message object with all the data that we want to add to our state. What we're going to do is, instead of setting it directly into our state and re-rendering, right? So instead of doing this step, we're going to not do that anymore, and instead we're going to push to Firebase. Or we're going to rather not push it. We're going to say add into Firebase. Right, we're going to put it into the database. Okay, so that's the steps that we're going to add in order to make this work. Cool. So how do we go about doing that? Well, in order to get this working, the first thing we're going to need to do is we're going to need to start getting what's called a reference to the database. So we need to know what database we want to be pushing data, adding data to, and where in this database, at what key do I want to be putting that data inside. So we can do that. What we're going to do to make that happen is we're going to import some functions from Firebase, from that Firebase library that we installed earlier, in order to be able to access and manipulate the database. So the functions we're going to start by importing is we're going to first import a function called getDatabase. Oh my gosh, spelled correctly. And we're going to import this from the Firebase library's database module. Now, we use database because that's the real-time database. If you were trying to talk about storage, you'd import from Firebase storage. If you're trying to talk about the Firestore, you'd import from Firestore. We're importing from the database because we're working with the real-time database. So this get database gets us a reference to the database. Talks to me about this thing. So because we want to add in Firebase, the first things we want to do is get a reference to the database. And we just call get database, and that gives us a reference to the database itself. This is a singleton accessor. It's 0 time. It's instantly fast. You can call get database wherever you want. Don't think about trying to make it like a global variable. Don't try to think about making it sort of at a higher level function, right? Just put it, we want it to exist inside of add message as part of adding a message. Just call it directly inside of there. If you try to create it outside of app or even outside of even outside of the structure, you're going to end up having some problems with things like effect hooks trying to reference it, or with it changing. And so you have a bunch of reference errors that fall apart. Don't try to create like a single global version. Don't worry about calling this function multiple times. It is an instantaneous function. It's literally just getting you the data from this thing. It's literally just getting you sort of this this ID, this URL. Basically, that's what it is. It's just sort of a shortcut for getting that work. Okay, so we call get database. I'm going to log out what the database looks like for a second, just so you can see it. I won't do this too often. So this again, I'm going to type a message and when I send my message, the database itself isn't actually the data. It's really just, again, a reference to the database and kind of tells you where it exists and kind of what to do with it. Okay, so that gives us access to the database. The next thing we need to know is where in this database we want to add our data. So the way that we do that is by using another function from Firebase called ref. And ref is going to get us a reference to a particular key in the database. By reference, we really mean like the address. Think of it like saying it's getting the URL. It's getting the address for where we want to be talking about in the database. It's not actually referencing the value there. We're not getting the data from the database itself. We're simply saying, get me a location in the database. All right, so we can create a reference for, I'm going to create this a message reference, and we do that by calling the ref function. The ref function takes two arguments. The first argument is going to be the database, which database we want to be referencing, where we want to find things into. And the second argument is a string that says which key do I want to be talking about. So for example, I could be talking about a message key. That's the key I'm interested in being able to refer to. I could have referred to put the first name key. I could refer to the last name key. I could sort of structure that any way that I want. So that creates our reference. And again, think of a reference as this is the address. Here. That's the address of where our message is going to go, where we want to put things. Okay, great. Cool. I'm going to go over, let's get something added in here, and then we'll go over how we can, we'll go clarify how we can adjust things. Well, no, we'll do that. So this refers to a message key, right? So for example, if I had a message here that was hello world, right? That refers to the message key. If I had something nested inside of here, maybe I had a name and the one that has a first key, the value is Joel. Right. If I want to refer to the name, the first key inside of name, right? So if I wanted to talk about the first name ref, here, let me delete this ones just to make sure we're being very clear. All right, get rid of those guys, get rid of that guy, and then we'll add one more last Ross. That's fine. Right, so I've got my name as first and last. If I want to talk about the first name key, or I can make a ref to my database. We wouldn't write name.first the way you would think about it writing it in JSON notation. Instead, we're going to use URL path syntax. So we're going to put slashes like there were folders, like there were URL segments between each piece. So this refers to now the name, the first value, right? The word value with first inside of name, right? First inside of name. So that's how you refer to things that are nested deeper into your database. You don't always have to sort of refer to this top level key. You would refer to a key that's sort of further down the line here. Right. And again, these are different addresses. All right, that's fine. Leave it there. Okay, and that's how we can then reference the address of a particular location in our database. Awesome. And again, be very clear. I'll even log this out just to make sure it's really, really clear. Right. If I log out the message ref, when I hit submit, right, my message ref does not contain the data. It's not a data at all. It's literally just the path, the direction on where, the address on where to find that data. A reference is an address. That's all it is. Great. Now that we have a reference, now that we have a location in the database, we can actually put something into that database. So there's a number of functions we can use to add things to a database. The most basic one is called set. And we can import the set function from database in order to call set and set something in that database. Now, here's where I deviate from, I think, the rest of the React and Firebase using world. Having a generic function called set drives me crazy. Like, I don't want to have like some random code and just as I'm setting my code, just randomly have the word set in here. Because my first thought is set what? What am I setting? Who is setting? Is like maybe I know because I'm talking about setting the database, but am I setting some state? Am I setting something else? Am I setting an object? Like set is so generic it's too generic for me to be able to work with. And I don't like having a function whose literal name is set. So instead, I like to alias this. So I'm going to use the as function in order to create a new nickname for that function. And I'm going to call it Firebase set. That way, when I'm writing my code down here, I can have a function called Firebase set, which is way more clear to me as a reader about what I'm actually trying to do. So that way, as I'm skimming through the code, I don't just have this random set without being clear about what exactly is getting set. It says Firebase set, so I know, I'm setting Firebase. Now I know what I'm talking about. Right. So I really like to import stuff as Firebase set in order to be able to talk about setting variables. All right. Now that we've got our Firebase set, we can go ahead and actually set it. So the set function takes two values. The first is going to be the reference. Where do we want to write some data into the database? In this case, we want to put it in message ref. And then the second value is what value do we want to put in that message ref? So I'm just going to, for the moment, hard code. There we go. This will be hello from React. So that's the message I want to set into my database. Okay. Now let's see an action. Now, in order to see an action, I'm going to strongly recommend that you sort of do side-by-side windows on this. So I'm going to go ahead and make kind of a little window here, and then we've got a little window here, so we can be able to see both of these things happening at once. Okay. Because again, you always want to have your database open when you're modifying something. So we refresh React. We're now going to type message, hello world. I'm going to hit send and watch what happens to the database. Message changes, and now it says message hello from React. We've updated the database, right? I hit send, and it sets the database. Now that variable has now changed. If we go back to our code, that's going to take me a little bit to get used to. If we go back to code, we can make it so it doesn't say hello from React. We can have it use, how about the message text variable? So what the user's typed in. Refresh this. So I can now say hello. And when I post it, the message is now hello. You see how it all turns yellow because it's changed? I am parrot. Changes to I am parrot. So we can use that set to be able to change what value is in the database. Now, of course, I'm currently just setting a string. But again, I can use any variable, any value in here. You can set any value that's a valid JSON value. So anything that's basically that is an object, an array, anything you want, you can set into the database. So we have our whole new message object. We can actually set that whole new message object into our database. All right. So there we go. Refresh this. Now I can say hello object. Hit send. My message now has an object assigned to it. So when I expand out my message, you can now see there's my whole object, right? So that what we've done is in our database, we made it so that it now has message is now an object. And that object is this guy that has a user ID, a username, user image, and so forth. Username, user ID, user image, so forth, including my text, hello object. I am a new message. We can send that. And notice that then it updates, it sets the message that now has the new text and the new timestamp. Because channel and user ID and all these other pieces didn't change, those values didn't get highlighted in yellow. So again, it's really useful to be able to have your app sort of visible side by side with you so that you can be able to see what's happening as you make the changes and like watch for those yellows, and I'll tell you when something's happening, which also helps you to see if something might be going wrong. Okay. To be clear, let's see. The set function replaces whatever value is currently at that reference with a brand new object. So for example, if I want to get rid of channel here, I'm going to get rid of that for a moment. You'll notice that then when I say no channel, refresh to make sure we're getting the code. Right. If I say no channel, that replaces the message with a version that doesn't have a channel that gets deleted. If you don't want to necessarily be like just outright replacing a value, you want to be like updating it, like merging in two objects together. There is also a function called update that you can import that just like set. So it'd be update. You can import it as Firebase update. And it works exactly the same way, but it merges two objects together to make those pieces come together. All right, so we can put our channel back in. To be clear, you don't just like with JavaScript, you actually don't have to have created a bunch of initial keys along the middle, right? I can actually go ahead and assign this to my first name ref. Oh, actually, no. Here, let's make a brand new ref. Let's make a multi-seg ref. It's got multiple segments. Graph the database, and this is going to be path to data. And I'm just going to write something out where it says path to data. And then I'm going to specify my new message to go into my multi-segment ref. And then I call multi-segment. I post that. And then you see it adds in a new path to data. And inside the data, there's my object, there's my value. So you don't need to worry about like predefining values or like making spots in the database for that data to go into. Just like assigning to an object, you can just start putting it in there and it'll show up and everything will work fine. Oh, oops. Sorry, going back to my title screen. Great. All right, let's go back to having this show up in the message graph. Great. And that's how we can be able to go and add in things into the database. Okay. Of course, you probably are noticing what's happening here is that every time I add a message, right? So here's a new message. Every time I do that, it's just changing the existing single message variable here, right? What I really want to make sure happens is that every time I add a new message, I want to actually add multiple messages. I want to make a new entry in the database, and we're going to have new values inside of that. Effectively, I want to be able to create an array of messages. So we can do that. The way that we're going to do that, and we're going to add these references, is we're going to use a different function. So instead of using set in order to set a particular single value to be sort of a single object, we're going to use another function here called push. And I'm once again going to import this Firebase push because, again, push is just really generic because it's like pushing to what? Push is going to let us push the value into an object as if it were an array. So let's just sort of push something into a key, adding sort of a new entry into that array instead of having to set and replace the key in that database. So what we can then do here is I'm going to create now a slightly different ref that we're going to use. So I'm going to create an all messages ref that's going to have a key for all messages. I'm just going to keep that distinct from messages so we can be able to see these pieces being different. And then instead of calling Firebase set in order to set a particular value, a particular sort of message in here, I'm going to call Firebase push and push to my all messages ref. And I'm going to push my new message object, right, which we're calling our new message object, into that key, into that reference. So I'm basically going to be pushing values into the all messages. So what we're going to create is we're going to create something that's, instead of having a message that has a single object, we're going to create all messages, which is going to be something like an array that we're going to keep pushing in new objects inside and be able to make this work. Basic idea. Okay. That in place, we're able to add messages. So let's see, let's refresh our app. Let's go to our page. And let's see, we're going to say this is now going to be message 1. We'll post it. All messages shows up with message inside. Message 2. Message 3. Notice it keeps updating things. Awesome. We've made 3 messages, so we should be able to expand all messages and see our 3 objects. And there's 3 things in here. They're kind of weird codes, but there's 3 things in here. If we expand those out, oh, there we go. Message 1. Message 2. Message 3. Okay, so what are these random strings that are going on here? So in Firebase, in our database, Firebase doesn't actually support arrays. You can't have an array inside of Firebase. And the reason is because if we use an array, each of these objects, each of these message objects is referenced by its index. Right, so the way that we refer to this object now is as the one index 0, this is index 1, and this is index 2, which means we would talk about all messages 0 and all messages 1. because this is a real-time database and we have it's a server, we've got lots of different clients potentially talking to it, it's possible that we might get multiple commands that are all coming at it effectively simultaneously. So for example, maybe one person says, right, maybe the first thing that happens, right, one person says, delete message 0. And another person says, I want to like message 0. Right. So one person is trying to like it's so cold out today, and the other person is trying to, and Penguin meanwhile trying to delete that message because they don't like it. Assuming the like functionality doesn't work here, but it's pretending that it did. Right. So these are sort of our two behaviors that get sent kind of all at once. Now, because they get sent effectively simultaneously, it becomes a race on what's going to happen. So, for example, if we first delete message, so if this was cold and this is warm, right? Because we got our two different messages here, right? If we first said delete message 0, then, oh, this is lucky. Make sure it's clear, right? Actually, no. I want to not message 0. I want to like message 0. Let's make it that. I'll make it really simple. So if we want to, right? So this person says I want to delete it, and this person says I want to like that message. So if the delete comes in first, then cold gets deleted. And now when the like message comes in, it says like message 0. Message 0 is the warm message, right? That's now message at index 0. So even though I clicked this heart to like the cold message, my like ends up going over to the warm message. And that becomes a problem, right? Of course, if the order of these were switched, then I would like, right, and then the cold message would be here. I would like the cold message, it gets a +1, and then it gets deleted, and that's the behavior that we want. But because we get that kind of race condition, we can't use arrays and their index position to refer to different values in the database. So instead of using an array with different objects, we are going to, in Firebase, it instead uses an object of objects, which means each one of these things needs a key. Key 1, key 2, key 3. So now I could talk about, say, delete, key 1, and I can now say like key 1, and then it doesn't matter what order they go in, right? So if I like key 1 and then it gets deleted, great. If I delete key 1 and then I try to like it, well, my like won't accidentally go over to key 2 or key 3 because it says to like key 1. Because our keys won't change the way index positions do in an array, everything works out better. So, in short, we don't actually have arrays inside of Firebase. We only have objects. And we need all these different unique keys. Now, of course, we could have, made these keys 1, 0, 1, 2, but that gets really awkward. Like, there's no order to an object. It's really not appropriate to use numeric values like that. So what Firebase does instead is when you use push, it will create a hash code, sort of a random unique string for that key. So in this case, our first key, sorry, a second, right? Our first key for our first message is going to be negative 03 UPQ. This one is going to be 03 UPR. This one is going to be negative 3 UPS F or U negative 03 UPS. Right. So we basically put all these things in order. These hash codes are generated based on a timestamp, and when you try to add them to the database, that's why they all look kind of similar for the moment, because I added them all rapidly one after another. If I add another message, right, this is a late message here, it gets added later, you'll notice its number is now slightly different. It's now got 03UR instead of U3P, right? So it does track those directly. So we now have unique keys for every single value in our database for being able to refer to these various pieces. This is how we sort of end up managing arrays of data. So what you'll want to really do is make sure that you create a spot for that is going to be an array. Like, this is my all messages. It's where I'm going to have all my messages show up. I can't just push them all directly into the database because that won't work. But I'm going to push them in here. Then they'll all get pushed in with their appropriate keys in order to be able to track down which thing is which. Okay. And that's how we can then be able to sort of set and push things into our database. Great. Oh, I keep going back to that screen. Good. All right. So that writes to the database, right? Now we're able to push new data into our database. So every time I'm writing a new message, it's now getting added into the database and everything's great. Of course, I want to now make sure that the data from my database shows up inside of my application, or I actually want to see what the user showed up. So in order to do that, we have to read from the database. All this operation we've done now is writing to the database. Notice that we're doing it in response to an event handler, right? Just the same way we were handling everything else. So this writes to our database. In order to read from the database, we're going to need to use another function, another structure from React. So the way that we're going to read from the real-time database is using what's called using a listener, similar to an event listener. The listener we're going to use is a function called onValue. OnValue is going to set us up a listener similar to how we added event listeners, right? Same way how we listen to like click events. In this case, we're going to listen for database update events. And anytime a database update event occurs, our listener will go off and it'll say, oh, the database changed. I can be able to respond to it. And I can grab that new data. I'll get that new data and be able to then react to it and show it on the screen. So we're going to use onValue to be able to say, set up a listener for our database. Now, because we're trying to set up a subscription, we're going to subscribe to the database, right? Anytime the database changes, we're going to get a new newsletter, a new update. Because we're setting up a subscription, that's a side effect of running our React app, right? Of rendering our component, right? When our app renders, I want to set up a listener for the database, but I only want to do that once. I only want to set up that listener the first time the app is rendered. I don't want to try to resubscribe every time the app gets re-rendered, because then every time our data changes, I'm going to resubscribe. So in order to do that, we're going to need to use an effect hook. So I've already got an effect hook here for managing the user, for sort of initially logging us in. I'm going to add in another effect hook to manage our database. So this is going to be we're going to add a use effect hook here. Here will be the function that we call. There's no situation in which I want to run this a second time. So again, its second argument is just going to be an empty array. And this is now going to be where we're going to set up, we're going to subscribe to the database. So we're going to listen for changes to the database. And we do that by calling the onValue function. All right. So how do we call what arguments does onValue take? Here. All right. The first thing that onValue is going to take is it's going to take a reference. We need to know which key in the database are we actually listening for, right? Which value are we interested in? Are we interested in all messages, message, name? Like, which thing do we want to listen for changes to? Oh my gosh. I'll get better at this, I promise. Code. There we go. So we're going to need a reference. Well, we know how to get references. The first thing we're going to do is we're going to call get database, right? Because we need to start getting our reference. Notice that I'm calling get database again. Did I call it twice in the same like module? Yes, that's good. That's fine. Don't try to think, oh, I don't want to have this line of code multiple times and move it outside like into app. Just call it inside of the sort of exact function it's used. It takes no time. There's no problem to do it. Always just do that. And I'm harping on this because a lot of students like try to make it clean, like try to clean it up and make it look nicer, and now it's causing problems because it's not actually making it look nicer. It's just causing problems. All right, so there's our reference. We're going to want a reference. Let's call this all messages ref. Actually, you know what? I just reuse the code from before. Right, there's my all messages ref. I called it scrolling. Right, so there's my references to all messages. Right, it's called the same thing. OnValue as its first argument will take that reference. That's the location we're going to listen to. We're going to listen to changes to all messages. We're not listening to changes to the whole database. So if I change that name, that first name, or I change something else, that won't affect this listener. We're only listening for that all messages key. Second, we're going to do is we're going to take in a callback function. And this function is going to have what's called a snapshot. We'll go over in a second. Which is going to be what do we want to do when the listener fires, right? And again, this is very similar to add event listener for Firebase value change and then a function. And I'm actually going to go ahead and just make this an arrow function here because otherwise it's going to drive me crazy. Cool. So that sets up our onValue. Awesome. So let me just log out this is happening, right? So this is going to be database changed. Right, we know that works. So let's see, refresh my database. Now, the first thing to notice is that when I refresh my page, my listener goes off, right? So my component renders, let's add this in. All right, so this is going to be rendering app. So as an effect hook, my component renders, and then my effect hook goes off. The effect hook connects to the database, and it says, hey, do I know what's in the database or not? And even though the database isn't actually changing, from the React application's perspective, it is, because the React application didn't know there was anything in the database. So when it connects to the database and sees there's a whole bunch of content there, it's like, oh, something has changed from my last understanding of this. So it downloads all that data, so we get that data for us to be able to display. So it says the database changed even the first time the component, the function, the application renders. If I add a new message, right? So this is going to be a new message. If I add that in, note that again, our new message gets added, and it tells us again that our database changed, right? That gets updated again. All right. I'm going to delete some of these extra console logs just to make sure we're not overwhelming ourselves. Great. In that case, our React application re-rendered because I changed the code, and so again, it says the database has changed. So this basically downloads a snapshot of the data anytime it sees the database changing. What we're doing is we're downloading the snapshot. So a snapshot is a Firebase object that sort of encapsulates all the data inside of that. We can get the actual data, the actual value from that by taking my snapshot argument here and calling the val function on it. So this will be my data value. So let's call it data. Right. If I console log that data, then, all right, my component re-renders, and you'll notice that when I render, it says oh, the database is different than what I thought because I didn't know there was a database because it's the first time connecting to it. Here's my data. Here's an object that contains all my keys, and those keys have these values, right? There's all my data. When a new value appears, another new message, parent's gonna be really talkative, and that's okay. It reruns again, and here's my new message that has even more data, right? It's text with another new message. So all my data is in there. So here is my data. This is my object that I'm getting. So to be very clear, this is a data object, right? It is an object, you can see it, that has keys 03UP, 03UPR, 03UPS, and each one of those objects then has an array of the values we get here. Cool. So this is a lot like fetch, right? We've now fetched the data from the database, and now we want to display it and we want to show it on the screen. The way that, of course, we will do that is we want to set it into our state, right? We want to make our state message array now have that set of data for us to be able to display. So instead of showing the data from my initial chat log, it should now be showing the data from my component, from my database. So I can call my set message state array function, right? In order to call my setter, in order to change, where'd it go? In order to change that state data, and I can set it to be this data object. Right, we're gonna go ahead and put it in the state in order to render. Cool. And when I do that, my app immediately crashes because this message array is trying to get filtered for us to be able to display stuff on the right channel. But because it's the thing I put in is an object, not an array, I can't actually filter it. So we can't just take my data object from, right? Because remember, this is an object, right? But what this needs to be an array. So I need to take this object and I need to convert it into an array. Well, luckily we can do that pretty simply. So what I do here is that I have an object, but it's got a whole bunch of keys inside, a whole bunch of values inside of it. So what I'd like to be able to do is be able to get an array of all those values. There's a couple of ways we can do that. My favorite is to actually say, well, let me start with, I can get an array of the keys really easily, right? So this is my data object. I'm going to console out for a moment so that nothing's crashing. Let's refresh, so we're back to it. Go. Okay, so I can get a list of keys, right? I can say get a key array by calling the object.keys function on my data object. We can log out the key array, right? That gives me my array of my strings, right? String 1, string 2, string 3, string 4, string 5. So this is now an array of strings. This needs to be an array of objects. If I have an array of one type, I want an array of another type. That's a mapping operation. I can map from my array of keys into an array of their values. So I can do that. Let's take my key array. So here's my structure, right? This will be my new array. Will be my old array, my key array. We're going to then map each value for each key string into this will be the transformed thing, and then not you, and then we're going to return transformed, right? So this thing in this case, the transform, the value you want to get is going to be go to my data object and get the value at that string, right? Get the value at that key, and then put that into new array. Right? And that's just a basic mapping operation. We can console.log our new array, see what it looks like. Did I spell something wrong? Transformed. Right. So that now gives me my array of objects, each of which is a chat object like I'm used to. So that's great. We can put that into our new array. This new array then is what I can actually go ahead and set to be. So this is actually now going to be, this is going to be my data array. Data array, just to make it really clear. I'm going to put my data array into my state. And ta-da, now we're seeing all the messages from the database, right? Here's all my new messages. If I add another new message, it gets added to the bottom. It shows up at the bottom there. I'm going to do a real quick change just to make this make the demo a little better. I'm going to swap the order of this so that it's ordering in reverse chronological order. So now when I say new message, it shows up at the top and it's very easy to see. Cool. So there's all my messages, right? They're all showing up. Every time I put a message in here, what's happening is, right, that message is getting added to the database. Because remember, we wrote some code. We wrote some code that says every time they post a message, that message gets added to the database. That's a one-directional operation, right? Me posting a message doesn't modify the state. It doesn't modify my app at all. All it does is says, take date message, put in database. This message adds to the database, right? New message goes in the database. All right. Then separately, it's like a separate lane on the highway, a totally different operation, says anything that happens to be in the database, let me download it and show it on the screen. So whenever something new pops into this database, I download it and show it on the screen. If something gets deleted from the database, that's a change. It gets downloaded and shown on the screen. Delete from the database. And I can delete a whole bunch of stuff from the database just to clean it up a little bit so we can see things happening. Right? Every time I delete a message here, it gets deleted from that place. We'll go down to 4. That'll be fine. Cool. So this is really important. When you're thinking about building out your Firebase database usage, is you really want to keep those two operations, reading and writing, updating the database and reading from the database, separate. They are totally separate things. They're like different lanes on the highway. One is going up, one is going down, and you don't want them driving on the same side of the street. That's going to cause crashes. So what we're going to do, right, is think about whenever I want to update the database, which is usually in response to a user updating a form, I get my data and I push it or set it into the database, and then I'm done. That's the end of it. That's the end. I don't need to say, oh, the database is updated, go read from it. I don't need to do anything else. I just say this operation goes up. It writes to the database. That's the one direction it goes. 100% separately, a totally different thing, right? Totally different chunks of code is saying, hey, I'm going to take anything that happens to be in the database, no matter where it came from, download it and put it on the screen, or rather add to my state, which puts it on the screen. So even though I'm getting the behavior of one function writes the database and the other one reads from the database, those things create this cycle, this loop, because they're both two-directional dimensions, right? One is updating the database, and then because it changes, that causes the other one to download. We're not actually doing both at the same time. You don't want to try to manipulate both at the same time, or again, you're going to cause crashes or conflicts because they're now trying to interact with each other in different ways. But yeah, this gives us the ability to add stuff into our database. Note that, let's see, the last thing that we want to do is kind of useful to do is we can take this transformed object, right, because it's an object, and I'm going to add in a new Firebase key property to it. And I'm going to take that key string and actually just add it in as a new value into my database. So instead of, in addition to having my channel, my text, and my message, and my timestamp, I'm also going to have the key on where it came from, right? I'm going to know that this, for example, that this message late is the 03UR message. That way, if I wanted to be able to do things like a message, when I click the like button, I'll know, oh, here's its address. Here's where I can go find it in that database. I know its initial key where it came from. I won't actually demo that because we won't have time. I'm trying to keep the video as short as I can. All right. So with that, we're able to, again, send messages, update the database, and everything hooks together. It's just fine. Note, of course, I can go to a different user. Go chat. I am Penguin. And actually, both my users show up, right? Because again, we can just send messages and it all shows into the database exactly the same way. Okay. Here's the really cool demo. So I've currently got this all happening in this kind of React window. If you open up a new incognito window in Chrome or a new private browser in Firefox or whatever they call them in their browsers, right? You go open it sort of like this other incognito kind of private browsing mode. This window doesn't share cookies or data or state with this piece. Actually, I guess we don't need to use incognito window. We're not using users. We can actually just, we can actually, that's more important when we're talking about doing user authentication. We can actually just open up two windows. This will be fine. Cool. Let's get rid of my well, here. Open up my terminal. Cool. I got my two windows side by side. Refresh. Let's make this one parrot. That one can be parrot. That's fine. We can make this one penguin. Chat. All right. Yeah, let's go to a different channel. How about we'll go to social? We don't have anything on social yet. I am parrot. Hello, parrot. I am penguin. Nice to meet you. Notice that as these are two different browsers, they're two different windows. And again, we could have done this in incognito. You could literally say they like have no connection at all. Every time I'm posting a message, it gets added to the database. And because it gets added to the database and each browser is listening to the database, it's downloading that data in real time. I'm getting real-time chatting going on. I can have multiple different users being able to talk to each other, or at least multiple different people pretending to be different users talking to each other. If I push this code up to the web, or I deployed it, anyone who accesses that data would all talking to that database. They'd all be able to chat together. We have now built a live working chat application by hooking it up directly to Firebase. And all we had to do that were two steps, independent steps. One was make sure that whenever we write a message, we push that into our Firebase database, right? It goes into our database. That's where it goes. There's our database. Oh God, I got way too many windows now for us to manage this. Right, it goes into our database for us to be able to see. And then anytime anything happens in our database as a second step, right? So that's pushing is one step. As a second step, we are listening for any changes to that field in the database and downloading them in order to set them into our state so that we can then render them. And that's the basic idea of how you can get data persistence through Firebase's structure. There can be some other places the complexity might show up is in how you're actually organizing your data in here, and sort of what you want to put things together, how you then want, which things you want to listen to, what components are listening to what. That's where sort of the design complexity shows up, but this is the basic syntax for how to get it working. I'll note that often you may want to nest these things pretty deeply. So for example, you might end up having something that might be like a user data value, and inside that user data, you might then have, again, like the name is going to be Joel, right? That's something you can create. Your user data might even have something like the user messages, right? And which can have then, some message, because it's going to be message, be key one, whose then value, this can be a message. Text is going to be, I am message one, right? You can end up having these fairly complex data structures here. Oh, no quotes on that, sorry. Right, so that I can end up having like user data, and each user data then keeps track of an individual user. Where this actually needs to have someone else together. So like structuring what this data structure looks like can get complex. I strongly recommend to deal with that is that you actually start by initially writing out your database, right? Go to a piece of scratch paper and say, what do I want this to look like? So maybe what I really want, and this is what I should have done ahead of time, right? I want to have a user data. And then for each user data, I need to have a user one, right? Here's my first user. And then user two, right? They're all going to have their own objects, their own data. User one's going to have a name, Joel. or it's going to have a name of whatever. User 2 will have a name of whatever. Right. This one is then going to have some messages. This one is going to have messages. Right. Is that you can write out the data schema ahead of time, figure out what you want your database to look like. And then as you're writing your code, you can update to these exact directions, right? You can say, make a reference to user data, sort of first user ID slash, so this would, for example, be a key to, right? Make a ref to something like user data slash user one slash name, right? That's how we can be able to talk to these individual pieces. So ways to work through Firebase, right? Get the database working, right? We talked about getting set up. Come up with your data schema, how you want to organize all the data in your database. It's non-relational. It's not a relational database. There's no SQL here. This is just a giant JSON object. So actually, like repeating code or repeating data is fine. Don't worry about that. Don't worry about trying to have them reference other parts of the database. Don't do that. It's all non-relational database. Come up with your data schema. Then I recommend writing down your pushing behavior first, write your writing behavior. So make it so that you can actually now write the data you want into that database and that schema. Debug that, make sure that's working perfectly. Once you've got a clean set of data in your database, then you can add in your listener to say, let me now download it and display it on the screen. And again, those are two separate operations. Get one working, then the other. Great. In any case, that gets us to our message. So we can now be able to, say goodbye. Multiple different servers in real time. Thank you.